Okay, so the recording has started. So let me share my screen. Okay. So I hope we can all see my screen now. If you can see my screen, let me know. I know if it thumbs up so I can know, and then we should continue. So basically, today we would be working on some different concepts in Python. So basically, we are going to be working more on Python variables and data types in Python. So we mentioned last class that, okay, we have identifiers, which are used to identify different variables from data types to functions to class. And then we have different data types. So I will just show us how variables are being assigned in Python. Now let's note I'm presently I'm using Jupyter Notebook. Why am I using Jupyter Notebook? If you are using a Python script like this, we would have to come to the terminal every now and then to run the script. But then with Jupyter Notebook, when I open a new code, I can put what I want in the new code, print Lawal, and run it. So I can run inside of it. I don't know it on, and then we can move on. So it's easy to use instead of just having to run the code. When we go more and be using the terminal to run the script. Hope we understand that. Hope we understand that. So yeah. To get Jupyter Notebook now, once you have Python installed and Python and VS Code installed, the same way we get Python inside of VS Code, you have to get Jupyter, just like Jupyter. By typing Jupyter, you would see different loading, you would see different extension, and I think the first one is what you are going to select, and then you can use it. So you can see this first one from Microsoft. Just download the first one from Microsoft. As I've installed it, you would be able to install it on the side and then be able to use it. And yeah, so much easy. Now to create a file, to create a new, okay, I'm not sure if you can see my screen. Let me increase it. Sorry, I'm much more better with using tiny fonts than bigger ones. This should be more okay now. To create a new file, just say the name of your file. I would say class 3 dot. If it is Python, you know we're going to put it .py. But now I want to make it a Jupyter Notebook file. So we are going to use .ipymb as name. .ipymb, and you click on it. So it's going to create it for you. So you can click on different codes, you can add different codes background, you can add markdown to it. Markdown is just like writing normal stuff instead of writing codes. I can understand. So now for Jupyter Notebook, you have to select the kernel. You have to select the kernel. Okay, select another kernel. Which kernel do you want to use? I see Python environment. I use Python 3.1. Python 3.10.11. I'll just click on it. So it will select that Python. It will select that kernel for me. So let me see To check if it is working, I would say print hello. Enter. I'm using shift enter to run it. Enter. So kindly, PC. So I think they're not using this. Let me just close this, please. Okay, to try to connect to a kernel. How is it connect to run? So it has connected successfully and now it's running hello for us. So now we can be able to run Python inside our Jupyter notebook. I hope that will to some text. I'll be copying some text in and then to explain. We'll control C. So we have different variables. So we have name equals Ada. So now this name is what? Is a variable. Name is the variable. While Ada is the main name, which is the data inside that variable. You understand? So now we have age is a variable, 20 as data inside this. So we have the same thing as height, we have same thing as student, is underscore student. So now we want to print Ada, we're going to say, let us run this because if we did not run it, it's not going to stick inside memory. Let's say print name now. It's going to print what for us? Okay, this is the markdown. It's going to print Ada for us. When I say print 20, print age, it's going to print 20 for because of what I've assigned it. So for in Python, assign that you don't have to do of just equals to when you do equals to it then automatically understand that you're assigning it. It automatically understands that you're assigning it. So now we have different data types. Let me create a little bit more a lot of code here that we can use by persistent. So when I say print age, we have different data types. We have data types ranging from string to numbers to floats. Yeah, string, integer, boolean. We have lists. We have tuples. We'll be working with that. We'll be seeing more of that later and later. See more of that later. More of lists, more of string, and then we'll be using it in different aspects. Now, to practice what we have, they will print out some stuff. So now I want to print name. I want to make it more interesting to see how it looks like. Now I'll place this in. See, print name is equals to name that we assigned earlier. Age is what the age that we assigned earlier. Height is what the height that we assigned earlier. Each student is true or false. So this is a boolean actually. True or false. We call it boolean. Boolean. We call this float. We call this float. We call this integer. And we call this string. Once I run this now, you can see it's to bring name for that because I have referenced it earlier. If not, it's not going to bring anything else for me. I'll say age equals I hope so that's yes, I hope we get and understand that. So that was how they are being used. So to print it out, you can then reference it and then make sense. So assigning data inside different variables. You can also check for data type. Perhaps working on a data and then you have something inside something and now check for which kind of data type is this safe. I'm not sure if it is this one or this one, or if it is, we're not sure of data types. You can actually check for the data type in Python. To check for the data type, what you're going to do is you say print type of what? Type of name. That's telling us what it is what that STR has means string. If I change it to age now, it says int to height. It will say it is what? It is float. And I say student underscore. This one for students. You say it is a boolean. Do you understand? So we can actually check the type. In our last time, casting different data types. You can cast from one box to work. There's string I can cast. Someone is talking. There's some ints like Mr. Lamide, you want to say something? Okay. There are some ints you can cast to string. There are some string you can cast to int, and there are some that you can cast. Let me give us a sample, some samples here. So let's say we have, I would say string 1, string 2, int 1, int 2. Now I'll assign some things to this. So this will be it is a string. It starts with that 2. Inside that 2 puts I would say 1.0. What Bamdele is actually in. So when I say this equal to int, I would say int 5. I would say equal 7.0. This 7.0 makes it equal. So now let me assign this inside the memory. I can change if I check for the type. Let me see, I'll just print all this type. Data types. So it's the one thing now in my copilot that's asking me to like data types of type str1, and I'll do this for the beginning. Str2 int 1 in 1 float 1. So now let's print all the. So you can see string. Second one is string. This one is now int. This is now I want to change this string. I want to change it to float. I want it to float. So I will now say. I will say. So I'll say float. So float. I'll now put it inside. So I'm casting over it. I'm thinking this one will float. Take over this. Float string 1. Float string 1, and I will say I will name it as new string now. New underscore str. If I try to print, We're trying to print now. I say print type new underscore string. You can see it's now a float. I have casted it to a float. I can see in. Now it can't cast to an int. Why? Because it is 1 point. Assuming it is 1 that I wrote, let me change this now. Let me enter. Change it to 1. You can see, assuming it is 1 that is inside, I can convert to int. This string now, can't think alphabets. It contains alphabets which are alphanumeric. So we don't find a way which we should be able to call it, but them to a string. This float can be to an int, it can also be to a string. This is to a float and also a string. So there are some scenarios where they work and where they can't work. You just have to understand where it could work. So let me say int, I'll say float int 1. 5.0. Int 1 is what? 5. It actually is 5.0 now. If I now say, let me try again. Let me now take over float 1. So it was 7.0, now lead to 7 instead of 7.0. 7. I hope it's understandable and it does make sense to understand that. So that's how to do the casting of different data types. Yeah, we have more and more data types. We have list, we have list, tuple, set, yeah, list of set. So now let us move on to another aspect, which is okay. So we should actually have an aspect which is none. So we actually use none. There's an aspect where you are working on something and then you have no value for it yet. Have no value for it. Then you want to see limit something. You can actually put none. So I say middle name now is what? Is none. When we try to print it, it is not empty. Like nothing is there presently. So let's try to run this. You can see is none. Class type, non type is nothing like that. How will you even solve this? If you don't want to put none inside, putting none is way okay because it lets you know that there is nothing inside. We actually say just empty string. We could actually have an empty string, but you don't take it as what? You don't take it as a string, but there is nothing inside the string. But then it will be very okay to have none than have an empty string. That's also a technique to it. Do you understand? That's also a technique to it. I hope we are getting it. We are getting it. So now, variable naming conventions. Variable naming conventions. Now, last class we talked about casing. To talk about camel case, Pascal case, and snake case. I hope we know how to do that. I work more with anyone, but I think snake case is still very good with me. So, variable naming convention. Use lowercase words separated by underscore. Use clear names that explain the data. Boolean variable often start with is, has, or can. So there are a lot of more and more. Don't start with don't start with a number. Don't start with a number. Start with a number or special character. Special character can be in between of your naming. Special. Okay. Yeah, help me. Special characters are not allowed except for underscore. You can see student underscore score. So the student score, that's easy to understand. Student underscore score. He has paid for student greater than 50. Student score greater than 50. So now it's eligible. It should come as a boolean, which is either true or false. Most of us putting condition, score has to be what? Greater than or that means student score here is 85. Greater than or equal to 50 is what? It is true. So to print here, I will say print illegible, print, you're going to print true. Let's try it out. I can see equals true. That's why, because student score here is 85. 85 is definitely greater than 50. That's why you have. Does that make sense? That makes sense. That's how we are trying to achieve it. So let's move on. You can use one name, name one, name underscore one, or yes, or name underscore one. But then it can't start with it can be number in between or number ending. Special characters are not allowed to do. Even trust me, I try to work with them. At the beginning, it seems to work. So you get errors. I hope that is very much clear enough. So let's move on. Converting one data type from. Let me bring this in to show to more explain the concept to us. So casting means converting from one type to another. String equals int. Now we now say we want to convert it now. We say number equals int number access. Now we're going to change. You can see convert a number or string to an integer. Convert it to an integer. Convert it to an integer. Print number 50. Now I'm going to say 250. It has changed it to int. 250 plus 50. If you say number as text plus 50, it's going to give us an error. I understand that. So price equals to 99.9. Price as integer. It's going to change to 99. Now print price as integer. It's going to give us 99. So let's run it. You can see 399. This is pretty much easy, pretty much simple. You can just try to one by one. Don't try to rush it. Okay. So now let's move on to arithmetic operators. Just bring example. We have different arithmetic operation. We have greater than, less than, so addition, or that these are comparison operators. We have addition, subtraction, this goes as brackets, division, flow, reminder, power. Yeah, we have flow, reminder, and power added to Python arithmetic operations, which I don't think is in normal operations, is normal mathematical operations. So let us bring it here. So we're having two variables here. We have 10, and we are assigning A as 10 and B as what? 3. B as 3. So now we're trying to perform different arithmetic operation on them. So normal addition, 10 plus 3 will give us 13. Subtraction, 10 minus 3 will give us 7. Multiplication will give us 30. So now 10 divided by 3 will give us 3.33. Now 10 floor division would give us what do we call it? Will give us only 3. It's not going to give us the remainder with it. Now remainder will give us 1, and then power will give us 10 raised to power 3. That's 10 times 10 times 10. That's 1,000. I hope you understand. Do you understand? Do you have any question with that? Is it clear enough? Someone is saying something? Okay. So now let us do it. So I think you understand the mathematics, but then if you don't understand, let me give you. It's just normal. This is normal 10 plus 3. That's you understand. We should be able to understand. Normal addition and subtraction. I think the one that can be difficult for us is this floor division and remainder. So floor division is not going to take us, it's not going to add the remainder to it. It's saying 10 divided by 3. We have 3 remainder 1, Abby. It's going to give us, okay, this is only 3. So now what it is doing is, say 10 divided by 3 equals 3R1. 3 remainder 1. 3 remainder 1. So floor division will only take this 3. It's not going to give us any remainder. Why? Remainder, which is this percentage sign, A modulus, people say modulus B, it gives us what? 1. Only give us 1, only the remainder. Now power, 10 raised to power 3, that means 10 times 10 times 10, that's 1,000. I think this looks pretty much straightforward and not that complicated. If you have any issues or we don't understand, please do let me know so I can know where to bring back we're not doing basic mathematics here. This is just basic. We are still doing basic mathematics. So yeah. Now moving on to the next concept is so moving on to the next agenda is the operator precedence. Multiplication happens before addition. Now let me show you, because this is very important for people that are doing more technical. Yeah, we're even doing more technical stuff. We are going to be doing ML and some other stuff. We should know the difference that happens at different points. So now we say 2 plus 3 plus 4. Multiplication will happen before what? Before addition. We're going to say 3 times 4, 12 plus 2. That is what? 14. But in the real way, we add this parenthesis, now going to be 2 plus 3. That is 5 times 4, 20. So we should actually know this. This used to confuse us a lot during our board mass class. Then, do you understand? So knowing the precedence, and it is something you can always do research on while trying it out, and then before this could actually bring a lot more issue for different calculation. Let's say somebody that is dealing with calculation of money now, and just doing it directly instead of doing it in the normal way. It can cause different ripples that we don't want. You understand? So yeah. Now let's move on to we do some operators next, which is comparison operators, assignment operators, and then logical operators. I think those are the next three things that we want to touch. Let me take it one by one. Let me not just bombard us. Let me take it step by step. Now, comparison operators. Comparison operators. Help it more, help it more. Give me more, give me more. So you can say A greater than B is 10 greater than 3. Which these ones will be giving us what? They'll be giving us these guys directly. They'll be giving us true or false. True or false. So what we expect from comparison operator is true or false, not an answer like what we've been getting before. So which is very much easy. Is 10 greater than 3 true? Is 10 equals to, if you say yeah, 1 equals to, let me explain this concept. 1 equals to, when I say A equals 10, I'm assigning 10 to A. When I say A equals 10, what I'm trying to say is A, is it equals to this 10? Let me put 5 now. Is A equals 5? Is A equals to 5? Yeah, I'm saying A is what? A is 10. So A is 10, yeah. But here I'm asking, is A equals to 5? That's why I bring it here. Is A equals to B, which is false. Now, is A greater, is A not equals to, not equals to, this means not equals to, exclamation mark before. Is A not equals to B? So we're saying true, it is not equals to B. 3 and 10 are not the same. Is A greater than or equals to B? True, it is greater than B. So greater than or equals to greater than B. Is A less than B? False. You can have less than or equals to B too. Do you understand? So we can have all those together, which is very, very much pretty much straightforward. It's pretty much straightforward. Yep. Please, do you understand? Any question, please? Any question, please? Okay, looks like we don't have any question. Looks like we don't have any question. Can we move on? Please give me a thumbs up if I can move on. Okay. I see one person giving me a thumbs up. Okay, so let's move on. Now, logical operators. Logical operators. This should be more okay, and I'm going to bring in something. I'm going to bring something in here. I'm going to bring something in here, which is the use of AI. So let's bring it here. Just like we did logics in our secondary school, I think science students, everyone should do it. Non-science students, I think we did logic at PS3. So Logic. So we have different logics in Python. Logic operators combined with condition. So score equals to 75. Attendance equals to 80. I like this here. Score is 75. Attendance is what? 80%. Print score greater than or equals to 50. So score greater than or equals to 50. That means this is true. This is true. And attendance greater than or equals to 70. This is also what? This is also true. Score greater than 90, false. Attendance greater than 70, true. False or true. Not score less than 50. True, true, true. So now we have to go into details into these logical operators because they are quite it quite has a principle which is true, false, false, true, 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 false, false, true, true, false. And for different, so let me look for the, I think let me draw the table. Let me look for the table. Um,
At 2000 videos.
Somebody saying something? Mr. Lamide. So let us explain what. Let me look for the images and image that we used to explain. Let us look for it and bring it up.
Which bank?
I think I have to.
Only point. You go put maybe only.
Okay, I'm telling you. Okay. So now let's see. Okay, let me open those. Okay, so let me share. Let us use W3 schools to um test out the logical operators. So let me stop sharing. Let me share my W3 school so that we can do that together. Share the screen. Okay, you can see this aspect now. So logical operators are used to combine conditional statements. We have the operator and, or and not, and or not. To return to if both statements are. That's what and does. Return true both statements are. We use it in our scenario. Return true if one of the statements is true. It returns true if one statement is true. I don't know if you get. It returns true if one of the statements is true. Now, reverse. Not reverse the result. Return false if the result is true, and returns true if the result is what? Is false. I hope you get me. I hope you get me. Does that make sense? Do we understand? Yeah, I think we should understand. Now let's see examples. Test if a number is greater than 0 and less than 10. X equals 5. Print x greater than 0. True. That's greater than 0. True. X less than 10. Also true. So, and we have and returns true if both are true. So this will be what? This will be true. Let me just try it again. Try it on your. Okay, why is that not working? Yeah, run this. Let me run this. You can see the answer is true because both are what? Both are true. Now, we say test if a number is less than 5 or greater than 10. Let's go to 5. Is x less than 5? No. X is equal to 5. X is 5. Or x greater than 10. This is true. This is false. This is true. But then we have or in between, not and. If it is and, it's going to be false. Let's try this out too. You can see it is false. It is false. Now, if I change this to and now, no, it should be coming again. It should be x less than 5. This is false. X greater than. So return or returns true if one of the statements is true. Returns true if one of the statements is true. X less than is true. X greater than 5. Okay. X greater than 5. X is 5. So x greater than 10. 5 is not greater than 10. 5 is not less than 10. Okay, both are false. 5 is not greater than 10. 5 is not less. 5 is not less than 5. So both are false. Yeah, sorry. Both are false. That's why it's giving us false. Both are false. Now, x 5 3 2, x less than 10 than not 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 true. So not false. This one tell us false now. It's tell us false. See, giving us false because this is what 5 is greater than this is true, but then I'm putting not in it. Assuming there is not, it's going to give us true directly. It will give us true directly. I hope we all got that. I hope we all got that, which is quite easy. Yes. Any question regarding these logical operators? It can get tricky. It can get tricky, but you just have to like calm down and try to understand. And we can read different operators here. We have more operators here: identity operators, membership operators, operator precedence. You can go as much as you feel like. So yes, we've done a lot with numbers. We've done a lot with numbers. Let's try to do some things with string. Let's try to do some things with string. And yeah, let's try to do some things with string and lists. String, list, tuple, dictionary. Can we finish all that today? I hope we should be able to do that. We are able to do that. That's going to be very nice. Let's work with string. Now, okay, let me share my other screen. Stop sharing. Okay. Yes, I hope you can see my screen now. Yes. 30%. Okay, I should still manage it. Now let me paste this in. So we have string as sequence of characters. Course, like which course are we taking? Python for AI engineering. So these are the characters inside of this now. You can perform different techniques inside these different techniques. I'll paste it one by one. So print course.lower. Because this is a string now. Dot lower means turn everything to a what? To a lowercase. When I click enter now, it's saying Python for AI engineering. This AI has been reduced to lowercase, everything now lowercase. So now if you are saying upper, change everything to what? To uppercase. Change everything to what? To uppercase. It should be like cut. There's something like this. Cut here. Okay, split here. No. It's not for this. You can see Python for AI engineering, showing everything to what? To capital letter. So now you can run this. Replace AI with what? With data. So now this one is going to say, once you replace the AI that is here with data. Now let's enter. As we have Python for data engineering. Now let's try to put something that is not correct here. Let's try to put IA. IA. It will be what? It will give us what we have here. It cannot see any IA inside this sentence. So it's giving us what? There's no IA if there is any IA out of data. So now let's put change Python to data. You can see data for AI engineering. If you now say change 0 to what? Change O. You have some O there. Change O to data. You can see every that I see Python inside data. So you have to be careful. You need to be careful while doing this. Instead all those O, is changing them to data, which you don't want. So you have to be careful about doing that. So I hope you understand this. So replace, you can use replace to just replace something inside of our string. So now we can split. When we say split, what split does is if you look for spaces, split them into a list. So let us run it. You can see now we have this Python for AI engineering as a whole. We have 4 words inside this Python for AI engineering. But now when you now say split, it's now splitting all of them into each chunk, each word. So we have Python for Python. This is a string. Python has a string on its own. For has a string on its own. AI has a string on its own. Engineering has a string on its own. Now we now have, what do we call it? Everything, all of them are now what? They are inside a list. They are inside a what? A list. We'll still come to list. We'll still come to list later. They're inside a list. I hope we get that. They're inside a list. That's what split does. And there are numerous of different other techniques that we can have with dot A, then for A, there's nothing for B. For B, let's see if there's something for B. Let's see. You can see dot capitalize, dot tasteful, dot center, dot count. There's just a lot. There's a lot that you can see. There's a lot that you can see. So you just have to try it out. Encode dot end this dot end and span tab, but trust me, you not be this guy every day. Use them when you need to, so you don't have to really worry about them. So those techniques, once you are trying to engage and trying to do stuff, you will be getting to use them more and more. I hope you understand. So that is it. Now, formatted printing. Formatted printing, yeah, let's talk about this. Name and course. Let us print print course, print name other. Okay, course, okay. Now I want to do formatted printing. I want to do formatted printing. So print. So there are different ways to print with Python. There are different ways, but this one I like it because you can reference variables inside of this. So I will show us different ways to print this out. It also say print name is learning this course. So let me print someone's name. Let me reassign name to someone. Whose name should I reassign name to? I'll leave that over here. I'll see Olamide. Let me reassign name here. I'll say name equal Olamide. For AI engineering. Yeah, no. I can't click on that. Control C. Yeah, yeah. Now, so you want to print Lamide is learning Python for AI engineering. I can also print in another way. You can print in another way. So you can say print. I can say name, comma. I'll put a space in between. It's learning. I can put comma in between. I'll say it's learning course. You see, Olamide is Python for AI engineering. Still the same. I think there should still be a way to that. There should be, I think there's still another way. I'm not sure if this would work, but then it's used to work. Print this is learning. Then you can now put dot. I don't think this would work. I'm not sure it would work, but there's a way. You can see this is the correct aspect. Print format. See the same thing is learning. We'll now say at the back, we now put course. I'm not sure if this will empty expression allowed. I'm not sure. There's a way, I would do my search on it, but there's a way to write it somewhere like this. But then we have that works. We have two different ways that works. Now, indexing. Indexing is, we say in to index. Python is not that we wrote for this course. Everything that we wrote are stored like inside the yes. This is stored as 0. Let me just invite you. Don't try to. I need this to explain. This is 0. This is 1. This is 2. This is 3. 5. This is 6. 6. 7. 7. This is 8. This is 9. This is 10. This is 10. And let us go. This is 11. This is 12. This is 13. 14. 15. 16. 17. 20. 21. This is 21. So 15. No. 16. 19, 19, 20, 21, yeah, 22, 22, 23, 24. Yeah. So Python is 0 is Python starts numbering from 0, not 1. Python starts numbering from 0, not 1. 0, 1, 2, 3, 4. Now, when I try to say course number what? Course number 0 to index, you're going to put it in this curly bracket, in this bracket. The key for me, we have to get what number 10 now. 10. It's actually this space. So even the space in between, those spaces are what they are. They also carry a number. Let me say 11. You can see A, that means the AI. When that's coming for this A, a way to like get what you want. And I'll show us how these are really, how they are useful coding. So you want to get -1 now. Yes. Why we start this guy from up here? If you have to start with -1, it's going to come from the end, -1. So we're not starting from, if you want to start from the end, we're not going to start from 0 again. We're going to start from -1. So this -1 is G. The indexing is to be very hard part. I hope I have a pen and paper to explain. 1 -2 and 7 -8. You understand? So you say that's we are coming, we are trying to count from the back, but from the front to start 0, 1, 2, 3. Does that make sense? Do you understand, please? Do you understand, guys? Really, I need to stop. Know that not too much of an answer, by the way. Okay. So now for the indexing itself, we can now slice something out. Okay, that's indexing. This one is slicing. You can slice a certain aspect out. You can slice that means you are cutting out from a range. I'm trying to cut out from a range. So to cut out from a range, print comes from 0 to 6. So Python. You can see Python. So this is just in Python. I'm cutting out from what? From 0 to 6 here. Now, if I say from 0 to 5, now 0 to 5, you can see just giving me pi 4 without n. So for Slicing out, you should say from where you want to start to where you want to end plus one. That is the syntax. Where you want to start to where you want to end plus one. So you're going to be print course starting to ending plus one. Now I now want to stop on what? I want to stop on n, which is 5. N, which is 5. So I have to add plus 1 to it. I have to stop on what? On plus 1, that's 6. So that I will get the main thing I want to get. I'll stop on 6. Let me add to get that. So that's what slicing deals with. That's what slicing deals with. And then we can also slice at the back. You can slice from -1 to what? Let's say -1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 to -12. What's happening? From -1. Okay, yep. Done a mistake. From -12 to -1. From -12 to actually the end. -1 to the end. So it has to start with a greater one and then come back. So I hope you just get this analogy. So yes, that will be where we'll be ending indexing and slicing of string. Now next class I will now talk more about um tuples, lists, dictionary, sets, and then different data types, different operations on them. I hope we've been able to get one or two from this. I hope next class we're able to move on to conditional statements, functions and collections, and then we should be able to move on to files, and then we've done something very, very much great. So so far, any question? Do we really understand? Do we get it? I hope, yeah. Explain. If you have any question, you can ask directly. If not, you can let me know. You can ask directly. If you are trying to practice and I have any issues, you can just let me know. Yep. Thank you, everyone. Thank you, Mr. Olamide. Nice having you here. Have a wonderful evening.